Assalamu alaikum students. A very happy morning to you all. Hope you are doing well. So the previous class we have gone through the topics, the periodic table, the classification of elements, and then the modern periodic laws, and the detail we detail discuss about the periods and groups. Now the most important topic are the group trends and the some basic definitions and some basic properties that every element have, and these properties are varies in periodic in periods and groups. So now, first of all, we will see here the topics that we are going to be covered in this class today is atomic radius and its trends, ionization energy, electron affinity, shielding effect, and electronegativity. These all are the those topics that we are going to discuss in today's lecture. So moving towards our first slide, the first thing we are going to discuss is atomic radius. So what is basically atomic radius, students? We know that the atom is the smallest particle of matter. In this universe, the atom is the smallest unit in this living world, and it is cannot be easily seen with naked eyes. So it's a common sense that if you can't see anything with the naked eyes and it is very 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 small, so how can you measure the radius of that atom? So atoms are so small that is impossible to see atoms even with the powerful optical microscope, and we want a high resolution electron microscopes to see the atomic radius. Otherwise we can't see with the very good quality and powerful optical microscope even. So the size of a single atom therefore cannot be directly measured, and however some techniques have been developed which can measure the distance between the center of the two bonded atoms of any element. So scientists propose a new technique to measure the atomic radius or atomic size between the atoms, that they consider the two bounded atoms, and they consider the two bounded atoms and they measure the central distance from the nucleus of both the atoms. And this is the internuclear distance, the nucleus of first atom to the nucleus of the second atom. The distance between this is known as internuclear distance. And you know that the diameter, the distance when divided by 2, cut into the half, that it forms a radius. So in this way the scientists can obtain the atomic radius of any kind of an atom. So half of the distance is considered to be the radius of an atom. यानी कि हमारे पास एक एटम का रेडियस मालूम करना बहुत मुश्किल है, क्योंकि वो बहुत छोटे साइज का होता है और इजीली हमें नजर भी नहीं आता नेकेड आइज से। तो क्या होता है, हमारे पास साइंटिस्ट ने एक टेक्निक डेवलप की जिसमें उन्होंने कहा कि जब दो एटम्स आपस में बाउंड होते हैं, तो एक एटम की न्यूक्लियस से लेके दूसरे एटम की न्यूक्लियस के दरमियान जितना डिस्टेंस है उसका हाफ कर लो, तो वो कहलाएगा एटॉमिक रेडियस। And then the unit that is used to represent the atomic radius of an atom is called angstrom unit, that is represented by capital A, and 1 angstrom is equals to 10 is to power minus 8. Okay, 10 is to power minus 8 centimeter. So this is the way that scientists can measure easily the atomic radius of any atom. Now, what are the trends of atomic radius in periodic table? Means that either the atomic radius increases in the group, or either it is increases in the period or decreases. Let's see what will have happen. So in groups in the periodic table, that atomic radius increases from top to bottom. Here you can see that the atomic radius increases in groups. What are groups? Groups are vertical columns starting from top to bottom, and from top to bottom in a group the atomic radius increases. What is the reason behind this? Because you know that down the group we have a lot of number of electrons added. Like that in the periodic table, the first element in a group is hydrogen, having a 1 electron. Then lithium, having a 3 electrons. Then sodium 11, potassium 19, rubidium 37. You can see that the rapidly increasing number of electrons in the groups increases the number of shell. Obvious, you have to accommodate the increasing the number of electrons into the new shells. So you added up to the you added more shells in the structure, and if the more shells being added in the structure, you know that the structure will getting wide, the structure that radius will getting increase. ओके, यानी कि जब भी हमारे पास डाउन द ग्रुप हम बात करते हैं तो हमारे पास नंबर ऑफ इलेक्ट्रॉन्स बढ़ जाते हैं। नंबर ऑफ इलेक्ट्रॉन्स बढ़ने की वजह से हमारे पास उनको एकोमोडेट करने के लिए, उनको जगह देने के लिए हमें शेल्स और लाने पड़ेंगे, क्योंकि आपको पता है हर एक स्पेसिफिक शेल की कैपेसिटी होती है मैक्सिमम, उसके बाद मजीद इलेक्ट्रॉन उसके अंदर नहीं आते। तो उनको मजीद फिट करवाने के लिए हम लोग क्या करेंगे, और शेल्स ऐड करवाएंगे। तो जैसे जैसे हम डाउन द ग्रुप जा रहे हैं, नंबर ऑफ इलेक्ट्रॉन्स हमारे पास बढ़ रहे हैं, तो नंबर ऑफ शेल्स भी इंक्रीज हो रहे हैं। तो नंबर ऑफ शेल्स इंक्रीज हो रहे हैं, उसका एरिया इंक्रीज हो रहा है, यानी कि उसका पूरा रेडियस इंक्रीज हो रहा है। तो इस सिचुएशन में हमारे पास क्या होता है, ग्रुप्स के अंदर हमारे पास एटॉमिक रेडियस इंक्रीज होता है। अब जो ग्रुप में इंक्रीज होता है तो ऑब्वियस सी बात है कि हमारे पास पीरियड्स में एटॉमिक रेडियस क्या होगा, डिक्रीज होगा। अब पीरियड में एटॉमिक रेडियस डिक्रीज क्यों होगा? अगर हम पीरियड में बात करें, पीरियड्स क्या होते हैं, लेफ्ट से राइट की तरफ मुड़ रहे होते हैं, हॉरिजॉन्टली लेफ्ट टू राइट होते हैं। अब हमारे पास लेफ्ट टू राइट एटॉमिक रेडियस डिक्रीज होता है। अब इसका रीजन हमारे पास क्या है कि डिक्रीज हमारे पास इसलिए होता है क्योंकि हम जब भी लेफ्ट से राइट की तरफ मूव करते हैं पीरियड में, तो हर एक एटम का न्यूक्लियर चार्ज इंक्रीज होता रहता है। जब न्यूक्लियर चार्ज इंक्रीज होगा, यानी कि न्यूक्लियस के ऊपर चार्ज क्या होता है, पॉजिटिव चार्ज होता है। और हमारे पास बाहर न्यूक्लियस के क्या है, इलेक्ट्रॉन्स है, जिनके पास क्या है, माइनस चार्ज है। तो हमें पता है कि पॉजिटिव हमेशा माइनस को अपनी तरफ अट्रैक्ट करवाएगा। अब क्या करता है, न्यूक्लियस अपने आप को पॉजिटिवली चार्ज करता है और अपने चार्ज को बढ़ाता रहता है टुवर्ड्स मूविंग राइट। अब जैसे जैसे हम लेफ्ट टू राइट जाते हैं तो न्यूक्लियर चार्ज बढ़ता है, तो हमारे पास क्या होता है, मजीद जो इलेक्ट्रॉन्स होते हैं वो करीब करीब आना स्टार्ट हो जाते हैं। जिसकी वजह से हमारे पास क्या होता है, जो नंबर ऑफ शेल्स हैं वो बहुत न्यूक्लियस के करीब करीब आ जाते हैं, यानी कि वो कंसंट्रेट होते रहते हैं, और एरिया जो हमारे पास होता है एटॉमिक का, एटम का, वो कम होता रहता है। तो अब क्या होगा, एज अ पॉजिटिव न्यूक्लियर चार्ज इंक्रीजेस, द नेगेटिवली चार्ज इलेक्ट्रॉन्स इन द शेल्स आर पुल्ड क्लोजर टू द न्यूक्लियस, thus the size of the outermost shell becomes gradually smaller. Yes, that is the cause that when you see that nuclear charge is getting increased gradually, then gradually the number of shells are containing electrons moving close towards the nucleus of an atom, thus resulting in the concentration or the shrinking of the size of the atom. Thus, in the period, the atomic radius decreases. Got my point? Now the next property next that we are going to deal. So first of all, you can see here that we have atomic radius decreases in the period. This is the lithium, beryllium, boron. You can see that there is a gradual decrease in the size of an atom. And why this gradual decrease in the size of atom is observed in the period moving from left to right? Because from moving towards left to right, the nuclear charge increases. And the nuclear charge increase results in the shrinking of the number of shells, because the shrinking of the shells happen because the हमारा जो nucleus है, it contains a positive charge, and the electrons revolving around the nucleus is containing the negative charge. So the positive always attracts the negative particles. Therefore nucleus tries to get closer the electrons towards its central nucleus, and then the shrinking the atomic size all over. And if we are going to discuss about the group, so in group you can see that atomic radius increases. And why this increasing atomic radius in group? Because you can as I foretold you that down the group we are going to see that the number of electrons are increasing rapidly. So these rapid number of electrons increment resulting in the addition of number of shells. So if the number of shells added in the atomic structure, then you have a common sense, and this is obvious that the size will getting increased. It will have a greater surface area, so that atomic radius increases. This is the basically trend in the periodic table of atomic mass that is followed till now. And now moving towards the next property, ionization energy. Yes, class, what basically the ionization energy is? So ionization energy is the minimum amount of energy required to remove an electron from a gaseous state and measured in kilojoules per mole. Yes. अब क्या होता है, फॉर एग्जाम्पल हमारे पास कोई भी एक एटम है वो गैशियस स्टेट में, और हमें उस एटम के गैशियस स्टेट में होते हुए उसकी जो लास्ट शेल का एक इलेक्ट्रॉन है वो इलेक्ट्रॉन रिमूव करवाना हो। अब यू नो दैट कि हमें किसी भी एटम से इलेक्ट्रॉन रिमूव करवाने के लिए या बॉन्ड ब्रेकिंग करने के लिए हमारे पास क्या होता है, एनर्जी को देना पड़ता है। अब वो एनर्जी जो हमारे पास रिक्वायर्ड है किसी भी गैशियस एटम के लास्ट शेल में से एक इलेक्ट्रॉन को निकालने के लिए, उस एनर्जी का नाम है आयोनाइजेशन एनर्जी। जैसे कि here you can see that this is an atom containing two electrons gaseous state में। Now the energy is given towards this electron, and this electron escapes out or leaves its shell and getting come outside, and this atom is get ionized. So the electron removed, and this removal needs energy, and the energy that used to remove an electron from the valence shell of a gaseous atom, this type of energy is known as ionization energy. And now ionization energy depends upon atomic size and nuclear charge. Why? Because you know that the greater the atomic size, the lesser will be the effect of nucleus on the outermost electron. You know that if you are moving away from the nucleus, so then the electrostatic force between the electron and the nucleus will be lesser. So if the electrostatic force will be lesser, there's not such a need of giving the high energy to move an electron. There is a weak force, so then the electron can be easily removed by giving a minimum amount of energy, and thus the ionization energy decreases if the atomic size increases. And if the nuclear charge increases, so the shells come closer towards the nucleus and the electrostatic force become more and more higher. So thus for removing of electrons, you must have to give the higher amount of energy to remove an electron from the gaseous atom. Thus, the higher and the other thing that higher ionization energy means removal of electron is more difficult. Yes, because that electron is much nearer to the nucleus and having a greater electrostatic force. So there's a need of higher ionization energy to move an electron. It is not an easy task for an atom to lose the electrons when the nuclear charge is high. Now, what are the basically trends of ionization energy? In the periods, if we move from left to right, the value of ionization energy increases. The ionization energy value increases, as I have told you, it because of size of atom reduce. Because from left to right, we have dealt with the nuclear charge, that the nuclear charge in the period increases. And if the nuclear charge increases, so you know that the electrons come closer towards the nucleus. It means that the electrons have a higher force of attraction with the nucleus. And this higher force, this greater force cannot be easily break down by giving a less energy. So by giving the very high amount of energy, the atom can be removed. Otherwise, by giving the less amount of energy, the atom can be not removed in the periods. Okay. So the value of ionization energy increases in the period. And in the groups, the ionization energy decreases. Why this decreases? Because you know that in groups, the atomic radius increases, the number of shells are added, and the outermost shell is too far from the nucleus. That means that it has the lesser and the least electrostatic force between the nucleus and the valence electrons. Thus, this weak force can easily be broken down and easily be cope up by the giving the less amount of energy, and the electrons can be easily removed from the last shell. Now moving towards the trend, here you can see that in the period the ionization energy increases, and down the group the ionization energy decreases, because we have seen that the atomic size increases down the group, and in the period the atomic size decreases. Therefore the in period the ionization energy increases. Now the next property is electron affinity. It is the opposite of ionization energy. Okay. The electron affinity is the amount of energy released when an electron is added in the outermost shell of a gaseous atom. What is ionization energy? Ionization energy is the energy need to remove an electron from the gaseous atom. And what is electron affinity? The energy released when an electron is added in the gaseous atom. That was removal in ionization energy. But in electron affinity, we are adding up the electron in the outermost shell of gaseous atom. So you also know that when the some electron is ended or some bond is formed between any compound, so the energy releases. It's an exothermic reaction. So when the electron is added in the gaseous atom outermost shell, so the amount of energy that release at that moment is known as electron affinity. It is measured in kilojoules per mole, and ionization energy is also measured in kilojoules per mole. Affinity means what? Attraction. Okay, therefore electron affinity means tendency to accept electron to form an anion. And electron affinity is the property of an element, that how much tendency it have to accept the electrons coming from an anion. So here you can see that this is an atom, and this is an electron that is to be added in this compound, in this atom. So after adding this electron in this atom, you can see that some amount of energy release out of it, and this energy is referred to electron affinity. Okay. Now what are the basic trends? So periods में हमारे पास क्या है? In a period, the electron affinity increases. Why? Because you know that again the atomic size decreases. If the atomic size decreases, so the attraction between the nucleus and the electrons increases, and there is lesser chance that electron can be added up to easily in the outermost shell. Now we are dealing with the groups. So in a group, electron affinity value decreases from top to bottom because the size of an atom increase. Yes, like that in when the size of an atom is increases, so the electrons can be easily fitted into the outermost shell because it is further far away from the nucleus. So this is the trend of electron affinity in the periodic table. Now the next property is shielding effect. What is basically shielding effect is? You can see here the shielding effect is defined as reduction in effective nuclear charge on the valence electrons due to presence of inner shell electrons. यह shielding effect क्या है? हमारे पास valence electrons पर हमारे पास nuclear charge का कम हो जाना. अब ये होता किस तरह है कि होता क्या है? The electrons present between the nucleus and valence shell of an atom reduce the nuclear charge effect on electron present in outermost shell. Yes, if you see a diagram here, wait, if you see a diagram here, so this is the nucleus, and around the nucleus, these are the inner electrons. The green color particles are inner electrons, these, okay? And the red are the outermost electrons present in the valence shell. So what will happen? The nucleus holds these inner electrons towards itself, and the nuclear charge effect on the outermost electron is lesser. And these internal shielding effect, this forms a shield. When the nucleus holds the inner shell's electrons towards itself, it forms a shield. And this shield is working as a shielding effect towards any kind of other electron to be happen or to be fitted or to be removed from that atom. Okay, shielding effect क्या है कि हमारे पास जब भी न्यूक्लियर चार्ज बढ़ता है तो हमारे पास आउटर मोस्ट शेल और न्यूक्लियर चार्ज के दरमियान जितने भी इलेक्ट्रॉन्स होते हैं, जितने भी शेल्स होते हैं, वो तमाम न्यूक्लियस इनको अपने पास खींच के रखता है. अब जिसकी वजह से क्या होता है? अंदर एक शील्डिंग इफेक्ट डेवलप हो जाता है, जिसकी वजह से क्या होता है कि हमारे पास अंदर के जो इलेक्ट्रॉन्स हैं वो स्टेबल रहते हैं. ना तो वो बाहर जा सकते हैं, ना तो वहां से कोई इलेक्ट्रॉन अंदर आ सकता है. क्यों? क्योंकि हमारे पास बाहर क्या बॉडी गार्ड्स खड़े हुए हैं, आउटर इलेक्ट्रॉन्स खड़े हुए हैं, और अंदर किसने संभाला हुआ है? न्यूक्लियस ने सारा काम संभाला हुआ है. तो ये हमारे पास क्या कहलाता है? शील्डिंग इफेक्ट कहलाता है. अब शील्डिंग इफेक्ट का ट्रेंड हमारे पास क्या है? द शील्डिंग इफेक्ट इंक्रीजेस डाउन द ग्रुप. यू नो दैट शील्डिंग इफेक्ट हमारे पास क्या होता है? डाउन द ग्रुप इंक्रीज होता है, और हमारे पास पीरियड में हमारे पास क्या होता है? सेम रहता है. ठीक है. Now the last property that we are going to deal in this topic is electronegativity. What is basically electronegativity? So electronegativity is the ability of an atom to attract the shared pair of electron towards itself in a molecule is called electronegativity. यानी किसी भी एटम की वो प्रॉपर्टी जो वो दूसरे एटम से उसका पेयर ऑफ इलेक्ट्रॉन को छीन ले, उस प्रॉपर्टी को इलेक्ट्रोनेगेटिविटी बोलते हैं. यानी इलेक्ट्रोनेगेटिविटी क्या होता है कि एक एटम की वो ताकत जो अपने शेल के अंदर किसी भी एटम और एटम के दो इलेक्ट्रॉन्स को खींच के अपने शेल में डाल दे, उसको क्या कहते हैं? इलेक्ट्रोनेगेटिविटी. द ट्रेंड ऑफ इलेक्ट्रोनेगेटिविटी इज सेम एज आयनाइजेशन एनर्जी. इसका ट्रेंड हमारे पास आयनाइजेशन और इलेक्ट्रॉन एफिनिटी के सेम ही है. It increases from left to right in period due to increase in nuclear charge, वही रीजन बन रहा है, and which decrease the distance from nucleus and shared pair electron. Electronegativity क्या है? एक डायग्राम से समझते हैं. वेरी फनी डायग्राम and very good diagram. Yes, see this. This is an atom, and this atom is attracting the shared pair of electron. This is shared pair of electron, and this shared pair of electron is attracted by this atom. So this property of an atom to attract the shared pair of electron towards itself is called as electronegativity. Again, what is electronegativity? The ability of an atom to attract the shared pair of electron towards itself is known as electronegativity. Okay, class, thank you so much for your cooperation. I hope so that all the properties and all the terminologies are understood by you very thoroughly. And still, if you have any confusion and if you have any question regardless of this topic, so you can ask me in your classroom, and inshallah I will clear your all confusions. So take care. Goodbye. Allah Hafiz.